that Earth is protected. Protected by its atmosphere. Protected by its magnetic field. Protected by distance, scale, and cosmic luck. We look up at the night sky and assume that the universe is dangerous, but Earth is somehow exempt. That assumption has shaped how we think about our planet, our future, and even our survival. But over the last few decades, scientists have quietly realized something unsettling. Earth's safety net, the invisible system that shields life from space, is thinner, more fragile, and more temporary than we once believed. This is not a story about apocalypse. It's a story about limits, because the same forces that make Earth habitable are also constantly eroding the very protections we depend on. And today, we're going to explore how close that balance really is. Welcome to Fragile Universe, a channel about deep universe and its science. If you're curious about space, science, and the hidden forces keeping us alive, consider subscribing Fragile Universe. In today's episode, we're going to uncover why Earth's protective shield is weakening and what that means for the future of life on our planet. When scientists talk about Earth's protection from space, they're usually referring to three interconnected systems. First, the magnetosphere, Earth's magnetic bubble, generated deep inside the planet. Second, the atmosphere, a thin layer of gas that absorbs radiation and burns up incoming debris. And third, distance and timing, our position in the solar system and the current phase of the sun's life. None of these are permanent. None of them are guaranteed. And all three are slowly changing. The most important and least visible is the magnetosphere. Earth's magnetic field is generated by molten iron moving inside the planet's outer core. This movement creates electric currents. Those currents generate magnetism, and that magnetism extends tens of thousands of kilometers into space. This magnetic field deflects solar wind, a constant stream of charged particles flowing outward from the sun. Without it, Earth would be directly exposed. We know this because we can see what happens to planets that lost their magnetic fields. Mars is the clearest example. Billions of years ago, Mars looked very different. It had rivers, lakes, possibly even oceans. But Mars lost its magnetic field early in its history. Once that happened, the solar wind began stripping its atmosphere away, particle by particle. Over time, Mars went from a world that could support life to a cold, airless desert. Not because it was hit by a single catastrophe, but because its planetary shield failed. That same process is happening on Earth. Much more slowly, but it is happening. Measurements taken over the last 200 years show something surprising. Earth's magnetic field strength has been decreasing. On average, it weakens by about 5% per century. In some regions, the decline is much faster. One of those regions is known as the South Atlantic Anomaly, a growing area where the magnetic field is unusually weak. Satellites passing through it experience increased radiation, instrument malfunctions, data corruption. This is not theoretical. Space agencies actively plan around it. and this leads to a deeper concern. Earth's magnetic poles are not fixed. Over geological time, they flip. North becomes south. South becomes north. This has happened hundreds of times in Earth's history. The last full reversal occurred about 780,000 years ago. During a reversal, the magnetic field weakens. It becomes unstable. Protection against radiation is reduced. Importantly, reversals are not instant. They take thousands of years. Life has survived them before, but modern civilization has never experienced one. And that changes everything. Even with a strong magnetic field, Earth is not immune to solar activity. The Sun regularly releases massive eruptions called coronal mass ejections, or CMES. When directed at Earth, they can overload power grids, disable satellites, disrupt GPS and communications, damage electrical infrastructure. In 1859, a solar storm known as the Carrington event caused telegraph systems to fail across the world. If a storm of similar magnitude hit Earth today, the consequences would be far more severe. Modern civilization is deeply dependent on electronics, and our safety net was never designed for that level of dependence. Earth's atmosphere feels vast, but in cosmic terms, it's incredibly thin. If Earth were scaled down to the size of an apple, the atmosphere would be thinner than the apple's skin. It protects us from ultraviolet radiation, gamma rays, small meteoroids, but it does not stop everything. High-energy cosmic rays constantly penetrate it. Normally, Earth's magnetic field helps redirect those particles, which brings us back to the same fragile balance. Atmosphere and magnetosphere work together. If one weakens, the other becomes far less effective. None of this means Earth is about to become uninhabitable, but it does mean something important. Earth's safety is conditional, temporary, dynamic, dependent on systems deep inside the planet and far beyond it. We live during a stable phase. A quiet sun. A functioning magnetic field. A thick enough atmosphere. But stability in the universe is never permanent. Earth is not guaranteed. Its protection is not permanent. Its safety net is not indestructible. The magnetic shield that guards our world is dynamic, shifting, weakening, and changing over time. Life on Earth exists not because the universe is safe, but because Earth is rare, balanced, delicate, fragile. The more we learn about the universe, the more extraordinary our survival becomes. This is Fragile Universe, where we explore the thin line between existence and extinction. If this episode made you see Earth differently, like the video, subscribe to Fragile Universe, and share this with someone who looks at the night sky and wonders what's really out there. Because this universe is vast, and our place in it is far more fragile than we ever imagined.